Okay, so on Friday we will have the midterm exam, and you will take the exam at home or some location, not this classroom. I mean, I guess you can come to this classroom and work here if I don't know. I won't. Okay. Well, anyway, don't. The rule is you can't talk to anybody else. All right. And I've posted kind of a starting template there, and then and this and the questions will appear around 3 o'clock. Okay, a little bit after 3, you'll have 2 hours. Okay, and so anyway, what you will be doing is you're going to be downloading 2 files. Okay, AP data.food, data.3.food, and ap.item. Okay, and these are coming from Bureau of Labor Statistics. This is from our the U.S. government here. Okay, oops, maybe let me click this into a new and there's all sorts of stuff, and I'm looking at basically consumer price index, all urban consumers, and I'm gonna under the text files here. Oh wait, that's for everything, and I think I'm gonna say average price data. This is where I'm going for. Okay, under average price data, this is these are the files that we're going to download. Okay, and we're going to take a look at ap.data.3.food. This was updated very recently. They update them pretty much every single month. Okay, and so this was updated 5 days ago, May 10th, 2019, and it keeps track of all sorts of food items. Okay, and so this is just a big text file, and so what you're going to do is you are going to it'll appear like this, and you'll just right click this thing. So in your browser you'll right click, and you're going to click Save As, and then and wherever you're doing it, you're going to save it as ap.data.3.food, and then add a .txt ending to let your computer know that it's a text file. Okay, so so you'll do that. So that's the we're looking at the food items. This is the all of the items themselves, what they are. So you'll again open this up, right click it, and click Save As, and you'll save it as a .txt, ap.item.txt. Okay. And I think those are really the only 2 files you absolutely need for the data. And then this last document here, ap.txt, this contains a lot of information about what kind of information is stored in those data files. Okay, and so so make sure you read this, read this before Friday, so you're familiar with how the data is structured and formatted. Okay, and so that's just in the ap.txt average price data. Okay, and you can see there's all sorts of stuff stored in here. So they've gathered information on milk, fresh, whole, fortified per gallon. Okay, so this is how much 709,112 is a gallon of whole milk, and then you can see how much the gallon of skim milk and how much a gallon of low-fat milk cost. You can see how much one cost per can, a can of coffee costs, all sorts of stuff, right? They have other things. We're just going to look at the kind of the food items that they are tracking, but they have household things, gasoline, and all sorts of stuff. Okay, so we're just going to look at the food item data, and I've created kind of this starting template that you should be able to download and open up in a Jupyter notebook. So let me see. I want to make sure I'm not opening up the answers thing. Okay. And so, and I think this this should get you started as far as getting the data loaded. Okay. Hopefully you don't face too many issues here. And I would say just test this out tonight or tomorrow or sometime before Friday 3 p.m. You don't want to be struggling with this in case there is an issue, okay? And basically, I'll just make sure this runs here. Here, I'll go ahead and I'll just do kernel, restart, and clear output, and we'll just, did that not work? Okay, so here it is, okay? And okay, we'll load our libraries, and then we'll do read CSV on the text file. The separator is a tab, okay? And I'm going to go ahead and do that. It gives me a warning, okay? And there is a warning indeed. And the reason for that is because one of the columns is basically like blank, okay? So it gives me a warning, but I'm not going to deduct any points for warnings, okay? So it's fine. And if you read the this file on ap.txt, which gives information about the average price data, one of the things that that they tell us is that the series, the item code is the last 6 digits of the series ID. Okay, so the series ID is this big long thing, but the last 6 digits corresponds to the item code. So I'm going to strip all white space and then extract out the last 6 digits and store that as item code. And then if I take a look at the head of this thing, it says, item 7011111, 1980, January of 1980, so period is month 01. January 1980, it was 20.3 cents, okay? And then, this would require us to go to basically the items, and we would have to look up what, 7011111 is, and this is flour, white, all-purpose per pound, okay? So, a pound of flour in 1980 was around 20 cents, okay? In January of 1980. And I don't know, let's, I guess I can extend this, okay? And then by 1989, it was 24 cents, as far as 70111 goes, okay? But anyway, that's what we see, okay? Here is the data file that includes the item codes and the full name of these things, okay? And we can see this, and we can see 7011111 is flour, white, all-purpose per pound, and then 7011311 is rice, white, long grain, pre-cooked, and then I'm actually not sure what the difference is between pre-cooked and uncooked rice is, but anyway, these are different things. And then you've got the cost of spaghetti per pound and things like that, right? And then I've merged these two together. You know what, value, we probably need to tell pandas that value is going to be a float. You know what, maybe I'll do this. Food.value, we're going to replace with the food.value.asType float. And then, did that not work? Could not convert string to float. Oh, there's a something in here has a non-float. Okay, well, I think in the exercises I assign, I'll be sure to include an instruction like after you filter it, that and I'll make sure all of these questions are doable. That after you filter it, you'll probably want to convert the value to a float. Apparently, somewhere in our data file, they put in a dash for the value, and it's causing some issues. So we would have to kind of clean that up and either turn that into nans or something. Okay, so anyway, just kind of play around with this. You can do stuff and see, whatever. You could ask yourself questions and to kind of play around with here. Okay, is this all right? Questions about this? So you're going to be working with kind of consumer price index information on an item by item level from the U.S. government. So, the U.S. Bureau of Labor Statistics, U.S. government does a pretty thorough job of collecting this kind of information, like every single month. It's quite impressive, and they put in these numbers here. Okay. So anyway, we'll play around with that, and for I guess the rest of today, we'll take a look at last year's exam, which I've called the practice exam, and I guess I'll start off with the empty sandbox. Let me make a copy of this. Let me close and halt this one, and we'll call this midterm sandbox, I guess, in class. Okay, and I've already downloaded the BMX, the body measurements, and the demographics files. Okay, and I will load these in here. Okay, and so we've got that. The information on the body measurements is here. We'll bring in the demographics. The information on the demographics is there. We'll merge this data. The merged data is here on sequence number. Is that right? Okay. And then so here, kind of this is just like gender is equal to 1, and the age in months is less than 13. So these are all infants under age 13. Okay. So for all of these things, what I will need is information on this data dictionary and this data dictionary. Okay. So okay, and then the practice questions started off here. Okay, and this was after giving this last year. I learned that this was too many questions for a 2-hour exam, so we won't do that. Okay, so it starts off by saying calculate and display the mean weight of baby boys for each month from month 0 to 12, and you'll produce 13 values, 1 for each month. So under demographics, okay, we'll go to gender, and then and what we see is code is 1 is male and code 2 is female. Okay, so code 1 is male and code 2 is female, and so when we do this, this will filter down to males under 13 months of age. Okay, and if I do this, this will be girl babies under 13 months. So basically from 0 to 12 months in age. Okay, so this just kind of tells me how many observations we have. And so so to do this, what I want to do is I want to get an average. The question says we want the mean weight of baby boys for each month from month 0 to 12. Okay, so so what I'm going to do is so I can chain these dot locks to kind of say these are boys. Okay, boys under 13 months, or I could do 12 months and less. And that, so less than 13 is the same thing as doing less than or equal to 12. That's fine, right? So so that will filter down, and then maybe just to work with, I'll just call this baby boy. All right, and then we'll do baby boy, and I want to calculate the mean age per month, right? So so I'm going to do group by, and we'll do rid age mn. Well, here let's just first do take a look at the head. Okay. And okay, we've got maybe we'll just take a look at some of these things. Okay, so this is what we have. So just the age in months is right there. That's fine. And what we're going to do is we're going to do group by, and we'll do that. And what I want to do now is basically I just want to calculate the mean weight of the weight column. Okay, so if we look at the body measurements, okay, we can see we've got BMX weight. This is the column for weight. So I'm going to just say I want, so we're going to group by age, and then we're going to age in months. Then we're going to take the weight column, and we'll calculate the mean. Oh, I'm sorry, I don't need the dot. Okay, and there we go. Okay, so for 0 months I've got 4.79. You know what, this is, I don't like that these are floats. I'm gonna do something. Okay, I'm gonna do baby boy, and then I'm gonna create a column called age, and then we'll do baby boy dot age in months, and then I'll do as type int, and then we'll do the same thing based on age. Okay, that's a little bit easier for me to see. Okay, so we've got the mean age, or the mean weight for ages for mean weight of boys by month. Okay, is that all right? So we'll do the same thing, but for the girls now. Okay, so I'm going to just basically copy these, and copy these and paste these down here. Okay, and then we'll just do girls, baby girls, gender is going to be 2, and then we'll just baby girl, baby girl, Okay, and so there we go. We got the same calculations for girls. Okay. All right. Are there any questions on any of this stuff that I'm doing? Is this all right? Okay, so we found these things by that. Okay, so I think those were the kind of the first two questions. Calculate and display the mean weight of baby boys for each month, mean weight of baby girls for each month. Calculate and display the difference between the mean weight of boys and girls for each month, right? So, because our guiding question is, do baby boys weigh more than baby girls on average, right? What do you guys think? Do baby boys weigh more than baby girls on average? Yes, on average? Okay, well, we'll find out, right? Oops, okay, so so we'll create a data frame, all right? So I'm gonna create a months weights data frame. So I'm gonna do pandas.data.frame, all right? And then I've got two series, right? Oh, I should have saved these things. So this is this will be girl weights per month is equal to this. All right, and then let me just, so I need to save these series. Okay, and then to create a dictionary, we'll provide a dictionary, and this will do, we'll do boys is the key, and the value is boy weights per month, and then girls is the key, and then we'll do girl weights month, okay, and then we'll just ask to see the month weights data frame. So we've got that, and then we'll add a column here. Month weights, and we'll add a column called difference, and this will just be month weights dot boys minus month weights dot girls. Okay, I guess I called it boys and girl. I should have. And we'll do boys, girls. Okay, and then let's go ahead. Month weights. We'll take a look there, and that should be fine, I think. Okay, so that's the difference, and we see the difference is all positive here. So indeed, boys appear to weigh more than girls. Okay, and then make a line plot showing two lines, one for boys' mean weights and one for girls in a different color. Month will go on the X, and the mean weight will go on the Y-axis. Okay, so well, I mean, there's a few ways we can do this. We can just do month weights dot plot, and I think this will. No, I guess not. Okay. Well, all right. I'll just do boys dot plot, and then I'll do girls dot plot. Okay, and there's what we have there. If we wanted, we can add a label, and we'll call this boys, and this will be girls, and then we can do plt.legend. Did I not do? No, I guess not. Okay, so let me just import pyplot. Okay, and so there's a plot for the boys and the girls right there. Okay, what else do I need to do here? Okay. Month will go on the x-axis, mean weight on the y-axis. I think that's what I've got. I mean, I can add labels. plt.ylabel weight in pounds. Average weight in pounds, I don't know. And then I guess X label will be age in months. Okay, so we've got that. All right, and then make a scatter plot with linear regression lines for the baby boy's relationship between age and weight and the baby girl's relationship between age and weight. Okay, with Seaborn it says. Okay, so let me do import Seaborn as SNS. Okay, and then okay, so for Seaborn, I want to do linear regression. All right, so I think we'll just go ahead and do LM plot, and okay, and this is basically what we want. Okay, we want one for boys and one for girls. Okay, so we're going to basically do X for the age, Y for the weight, and the hue will be the sex. Okay, and we're going to just kind of take the data in our babies thing. Okay, so not baby boys and not baby girls, but we'll just do the original thing. So I think probably I have to come back, kind of do this. We're not gonna just select one gender. We'll select everybody here. We'll call this all babies. All right, and then we'll do SNS dot this basically. Okay, so LM plot, we want what do we call it? What is age again? Rid age MN. Okay, so X will be rid age MN, and then and then we've got BMX weight. Where BMX WT. Okay, so BMX WT, and then hue will be rid age rid gender. I forget. Let me find that line again. Okay, RI gender. Okay, I think this is what we have. Data comes from all babies. I don't think I need to specify markers or palette. Okay, we'll go ahead and we'll just try that. Okay, that looks good. That's what we want, I think. Make a scatter plot with linear regression lines. Okay, 5 points. Comment on what you see about the guiding question. Okay, additional, and all right. So basically, we would add something like it appears that I don't know. Probably you'd write more than that. On average, baby boys weigh more than baby girls. Okay, so that's kind of the first analysis where we took each gender and we kind of created these series: average age, average weight by month. Okay, and then we combined the two into a data frame. We made a plot, and every month the average weight of the boys is more than the average weight of the girls. And you know, this thing seems to indicate the same. And that's what we have. Yes, question.
Is it okay if we use reg plot?
What?
Reg plot?
Reg plot? Yeah, probably. I mean, I don't. Oh, reg plot doesn't support the argument hue. So, yeah. However, you know, all of these things, there's probably like 5 different ways, or even more ways to achieve the same answer. Okay, and I don't really care. So, so as long as you are doing it. So, so I'm not forcing you to do one thing and exactly only one thing. Okay. Now the next set of questions is height versus leg length versus arm length. Okay. What's the relationship between height and leg length and arm length? Does this relationship change with age, right? And so I think our general idea is that taller people have longer legs and longer arms, right? And that makes sense, okay? And so, so we're gonna try to see, you know, does this affect us, right? So we want all adults aged 20 and up who have all 3 measurements of height, upper leg length, and upper arm length, okay? And what's the correlation? Okay, so we're gonna ask for the correlation between standing height, upper leg length, standing height, upper arm. Okay, so we've got a bunch of correlation things, right? Okay, so let's just do, all right, so this will be section 2, height, leg length, and arm length. Okay, so I'm going to create take from our merged data. Our merged data, I want the columns for, so I'm going to do merged.location, and we're going to do all rows, and we're going to take the columns that we need. For body measurement, we need, so I'm going to search for height. Okay, standing height is BMX height. Okay, so I will take that. Okay, and I need upper leg length. So as far as body measurements, I'm going to look up leg length. Okay, BMX leg. All right, body measurement leg. And I also need upper arm length. So we'll go to the body measurements thing and we'll take arm. Okay, BMX arm length, upper leg length. This all makes sense here. Okay, so okay, so I'm sorry. Upper arm length is BMX arm L. And then, and we need to know, I said all adults aged 20 and up. Okay, so we're gonna go and we also need to get the age in from the demographics table. Okay, so we'll do age in years at screening. Okay, not the age in months, in age in years. Okay, so we've got rid age year. Okay, so and because I'm doing multiple columns, I provide a list of these things. Okay, so we'll go ahead and we'll do that. Let's just do q2.head and just take a look here. All right, okay, and then we'll filter down and we'll make this adults, and we'll do q2.location where we want q2 dot age in years is greater than or equal to 20. Okay, so we'll go ahead and do that. All right, and then let's do adults.info and just kind of take a look here. Okay. So we have some missing values because we've got things here, and I think our question says, we only want complete sets, right? So we're gonna get rid of anything missing. So it says for all adults age 20 who have all three measurements, okay, we want the correlation. All right, so we're gonna get rid of people without complete sets. So what we'll do is we'll do adults is equal to adults.drop NA, right? And if you if you forgot that, right? You can always ask pandas get rid of missing values, right? Remove data frame, remove missing values, and then the first thing will be data frame.drop NA. Okay, so if you forgot how to do that, you can look that up. All right, so I'm going to do adults.drop NA, and then we'll just check adults.info one more time. Okay, and so everybody there's 5,086, and they're all non-null, so we're good there, right? Okay, so we want the correlation. All right, so the question here was, what is the correlation here? So okay, so if you are not sure, right, so you can just say Python find correlation. Okay, and so correlation, we'll do correlation Python pandas. We can try that. Okay, and okay, so just you take the data frame and you dot core. Okay, so we'll do adults, and then we'll just select the variables. So standing height, BMX height, and upper leg length, BMX leg dot core. Whoops, something. Did I spell something wrong? Oh, BMX HT is height. Okay, wait. That's not what we want. Oh, correlation. Yeah, there we go. Okay, so we want that. Yeah, dot core. Okay, yeah, method equals that. Yeah, we don't need to worry about the method. Okay, you know what? I bet. And then I'm just gonna go ahead and do a BMX arm L. Okay. All right, and then there's our answers. Okay. So height and leg length has a correlation of 70.787. Height and arm length is 0.797, and leg and arm length is 0.629. Okay, next question. Okay, make adult age groups by decade. Adults aged 20 to 29.9, adults 30 to 39.9, so on and so forth, up into adults aged 80 plus. Use pandas.cut. If you use this, set the option right equals false. Okay, so let's look up pandas cut function. Okay, pandas.cut. How do we use pandas.cut? Pandas.cut will bin values into discrete intervals. Use cut when you need to segment and sort data values into bins. Okay, and then let's just take a look at some of the examples here. So cut this array into 3, okay, and it does that. You can also supply the bins. Okay, so int will define the number of equal width bins, or a sequence of scalars defines the bin allowing non-interval. Okay. All right. So so we'll go ahead and do pandas cut. So we'll do pd.cut, and we want to do this on the age groups, right? So we're going to do adults dot rid age year, I think. That RID age year. Okay, so we're gonna so that's what we want to cut, and we're gonna give it a sequence of scalars. So we're gonna do 20, 30, 40, 50, 60, 70, and 80, and then and the directions said use option right equals false, whether we should include the rightmost edge, and so we don't want that, so we'll set right equals false. Oops. Okay, and so this creates the 39. Why does 39 get? Okay, well maybe some people are missing their ages. That doesn't quite make sense. Hold on. All right, let me just do adults dot iloc 39. 38. Yeah, well, I'm not sure what's going on. Oh, it's not iloc. Oh, okay. Sorry. That's why. This person who's 80, so it's not 70. Oh, wait. 1, 2, 3, 4, 5, 6. Oh, what did I say? All right. So 20, 29, 30, 79. Okay. 80, 80 plus. Oh, okay. So, so we'll do 80, and then what I need is like one last one. I don't know. What's I'll just do 100, 150. Okay, and then all right. So the last person gets just binned into the group 80 to 150. All right. So that's why we had an issue. Okay, and then so I'm gonna go ahead and we'll store this as adults and make a new column called age group, age category, and we'll assign that result to there. Okay. Oops. Okay, and then we'll just take a look at adults.head. Okay, so that looks good. And then what was our question again? Okay, all right, so we did this. All right, so for each group, calculate the mean of the 3 values. Okay. For each group, calculate the mean of the 3 values. Okay, so we're going to go ahead and do adults.group by age underscore category, and then can I just do mean? I think I can just do mean. Oh wait, no, because then we're going to run into an issue. So okay, so I do need to select the columns that I want summarized. Okay, so it'll be these 3 columns. So if you want to supply more than one column, select more than one column, you have to put it inside, you put the list inside your bracket selection. Okay, so I've got it like this, all right? And then we'll ask for the mean. Okay, there we go. So height, leg, arm length, and that's what we've got. That seems reasonable. And then make a plot. Okay. How However, because leg length and arm length are similar in scale but height is not, create an adjusted height column which is the mean height minus 128. Okay, so wait, let me just do, I'm going to call this results, and we'll print the results, and then I'm going to run out of time, but let me just do results.plot. Okay, yeah, so we're on different scales here. So what we're going to do is we're going to add a new column called adjusted height, which is equal to results.bmx height minus 128. Okay, and then now if I do results.plot, and now we want BMX leg, BMX arm length, and adjusted height, and then dot plot. Okay, so there we go. There we go. So we've got leg length, arm length, and adjusted height, and they're plotted on the same graph. So we had to just tell it we didn't want that last column. And this is, you know, this was interesting. Okay, as the age goes up, okay, height and leg length seem to be like very strongly related. They just keep going down. Okay, but as far as arm length goes, that seems to remain fairly constant throughout someone's life, which I thought was really interesting. Okay, and it kind of makes sense, right? Like as you get older, we know people get shorter, and the reason why is because their legs are shrinking for whatever reason. You know, the legs are kind of subject to gravity, and that whatever reason, your bones decay or something, your legs are shrinking, maybe your spine shrinking a little bit. There's like a very strong, almost a straight direct relationship. But the length of your arms, that remains constant throughout time, which I thought was really interesting. Okay, I guess I'll post this, and you can spend some time to kind of go over, I guess the last section, education level and income. But yeah, good luck there.